I want to start, if I may, with a little poem. Intros require brevity. Kernels, protocols, complexity. Jupyter, much gravity. We'll try to bring some levity. All right, about us, I'm Paul Ivanov. I work at Bloomberg. Matthias Bussonnier, who will be speaking later, works at UC Berkeley. Those are points of contact. Thank you all very much again for coming. Whoop. Whoop. All right, we'll do it like this. All right, so let's start off with some history. And our thread begins with Ada Lovelace, mid-19th century, who was the first programmer. Then Grace Murray Hopper is our next stop on this journey, and she organized a team that led to the first compiler, with the idea being that we are going to stop writing machine instructions directly and say, manipulate this piece of memory, bring this into a register, and then add those two together. And then we start to have a higher level language, something that looks more like Fortran or C that you're familiar with, and that's in 1954. John McCarthy and his colleagues followed that up with Lisp and starting in 1958, with the idea being that we're going to have symbolic expressions, that we're not just going to tell the computer what to do in a high-level language. We're going to be able to manipulate abstract syntax trees and expressions and deal with them that way. Then at Xerox PARC in 1972, Alan Kay, Dan Engels, and Adele Goldberg developed Smalltalk. Smalltalk is a live system where you can, due to the message passing interface of all of the objects, you can actually edit the code that an object will run live and see that those changes operate throughout immediately. So that's kind of an amazing thing. There are still Smalltalk implementations today. Pharaoh is one of the leading ones. Encourage you to check that out. It's very exciting work, this thread that has continued. Our next stop on the journey is Guido van Rossum, starts the Python project in 1991. Hopefully you're all familiar with that. And Fernando Perez starts the IPython project in 2001 as an afternoon hack, a thesis procrastination project, as we heard on the in the keynote. This is a picture of Fernando. No, this is a picture of Ada Lovelace that I got from, and actually all my images, the ones that I didn't create, I got from Wikipedia. So Wikimedia, thank you. All right, so what was IPython originally? It's a read eval print loop. Python came with one. IPython was just a slightly better one. So when you would execute something in the Python prompt, 2 plus 2 equals 4, and you would be able to use the underscore in Python, and you still can, and you can use it in IPython as well to refer to that last result. But with IPython, you also got to, all of your results were saved, so you could call them by name, and you could even do it with an with an underscore one if you wanted to. So that was one of the things that you got. Another thing that you got was history. So if you start up the Python REPL, execute some code, and then exit it, restart the Python REPL again, you try the up arrow, it didn't work, it didn't do anything. So IPython got you that. Then you got tab completion. So if we have a variable like x here, and I'll try to raise things up so that more of you can see. We have a variable called x, we gave it a string called JupyterCon. If I press the tab key here, x.e, it tells me that there's a few different things available here. And I say, what is this ends with thing? So we just got tab completion. That's one feature. And with a question mark for the IPython kernel, you'll get a little doc string popping up here that tells you, oh, ends with takes these parameters. Here's what it does. Okay? And not only that, and this is a lesser known fact, in IPython, with the IPython kernel in Jupyter, if you have an object that is implemented in pure Python and you give it 2 question marks, you will get the entire source code of that object. Okay? And so here I've pulled up the OS path module, and here's the entire contents of that. And it doesn't work, it's not limited to modules, it works for individual functions so here's the join function and its source code there. Okay? So what is the next step in our journey toward the kernels, towards protocol? Well, what if we decouple execution from input? And so Brian and Fernando wrote up a prototype that started over spring break using 0MQ of messaging back and forth. And so you'll have the input on one side where you're typing in your code. You'll send that off for execution, get messages back that give you the results. The first released version of this was the Qt console in 2011, released with IPython 11, and it looked like this. So before all of this, you were just using the terminal, right? You were using command line interface, and so it was text only. The Qt console was the first thing that got us something where we could inline images because there was a rich WebKit-based interface there, and you could inline images. This is around the time that I started contributing more heavily to the project. I made a Vim IPython interface that did very much the same thing. You don't have images in Vim, but you are able to edit code in a native place, send it off for execution, get results back. You're able to start typing a command and tab complete it into a live namespace. So if you had x dot and then press tab, you could expand to ends with that way. And then the notebook was released in 2011. Okay, so here's an analogy of what it is. So I think we've all used the web, right? How many of you have written a web browser? Oh, yeah, all right. There's a couple of hands. Good, good. How many of you written a web server? Okay, a few people, right? And so we have a similar story here in that you don't have to. So most of us, I guess, for the recording, most people didn't raise their hand, right? But most people know what a web server is. Most people know what a web browser is. And sort of I'm trying to make the same analogy here with the Jupyter project is we have a client instead of a web browser in the Jupyter world that speaks the Jupyter protocol to a kernel, much like a web browser speaks HTTP to a web server, okay? So what is a kernel? Kernel is a computational engine. All it does is it accepts messages, performs actions, and sends out results. It does not have any relation to the operating system kernel that you may be familiar with. It's just the R nomenclature. The Jupyter kernel this is what it does. A computational engine receives messages, sends back, does some execution, sends back the results. Okay, and the client connects to exactly one kernel. It sends a message and to the kernel and waits for execution and then outputs whatever set of results it wants to. So this sort of decoupling allows the kernel to send all kinds of messages, and then the client decides, oh, I'm just a dummy terminal client. All I can do is display text, so that's what I'll do, right? Oh, well, I'm a rich web browser. I can do JavaScript fancy HTML things, and I'll do that. And there's a one-to-many kernel-to-clients relationship. So you could have a console, a Qt console, Vim IPython, and Jupyter Lab all talking to the same kernel. And the joke here is that my magic draw arrows here doesn't work. Thank you. Yeah, if I got one laugh, that's good. That's good. Yeah. Usually gets a bigger laugh. But all right. So why might you have different clients? Well, you have different affordances depending on the client, right? You didn't have multi-line editing in the terminal. You do today, but you didn't used to. The Qt console allowed for images, and the classic notebook, once we moved to the web browser, allows you to have images, video, JavaScript, you name it, these much richer interface. The console and the Qt console have no persistence beyond just saving the history of your input, whereas the notebook files allow you to save what you did, what got executed, what the results were, right? And you could save it to files in Vim IPython. All right. So there's many different sort of official clients. There's many third-party, wider Jovian ecosystem clients. Interact is one that's just a desktop client. Hydrogen is another one that hooks into the Atom editor, much like Vim IPython did, but allows for, because the Atom editor is a much richer interface, it actually allows for inlining of images and things like that, building little widgets with that. Okay, so I'm going to do a demo, but in order to do that, I sort of have to explain how So far, we've been talking about a client talking directly to a kernel. And that's not exactly what's happening in the notebook, right? So I just have a little sequence diagram here that explains what's going on in the notebook. How many of you are familiar with sequence diagrams? All right, fair number of you, but I'll walk you through it. So we have three actors here. We have the browser, the notebook, and the kernel. And time is going to be moving downward as I scroll down. All right, so the first thing that happens is a user browses to localhost notebook, some example notebook, okay? What happens is that the notebook server looks at that notebook file, figures out what kernel to start up, and fires off a message to the kernel to get that started, to get the 0MQ session to start up. The browser, in the meantime, has received the page that we're looking at here, but nothing has loaded. It's just the web application, just enough to start loading the actual notebook document and the session. So it grabs the actual notebook document through the Contents API so that it can start populating all the cells with all the different inputs and outputs that are going to be there. It parses that representation. And then once it does that, it's also ready to fetch and open a WebSocket connection to the server to be able to speak through the server to the kernel. Okay? So what we're going to have is once the WebSocket connection has started, the Jupyter protocol will travel from the web browser on the left to the web server in the middle, and then those messages will get translated and sort of changed up a little bit, split up among multiple 0MQ channels, and talk to the kernel. And that's the way that will work. So when the user types x equals 42 in a cell and executes that, that sends a message over WebSocket here to the web server forwards that to the kernel does some execution, sets x equal to 42 in its namespace, and then sends a message back saying, OK, execution done, and the web server follows that on and forwards that back to the web browser, and your input prompt, which was busy, is now set to the 1 because you got the execution count in a message. That make sense? Cool, lots of head nods. All right, so let's demo. What I have here is a little client. Let me go back 1 second to this. So what I've done is I've written a client that's going to intercept. So we have the web browser and the notebook server. I have a client that's going to be, in place of a web browser, be doing the same thing. And it turns out it's going to be using this sessions API. It has already made a connection over WebSockets to the notebook server as well. So I'll be able to send it messages and see what the messages look like coming back. And the way that I've done that is that it's sort of, it's a little, let me just send off an execution and then start. So what I've just done is send a basic execute example of 2 plus 2. And the server sent back these messages in reply to that. So the first message that is sent is over this channel called IOPub. So this is the analogy here is this is kind of like an email client, right? You might be subscribed to multiple mailing lists. Those are the channels. And you have different messages going through. And there are some that are threaded, some that are replies to previous messages. Others are new messages altogether. So the first message that the kernel sends to everyone, to this mailing list, everyone that's listening right now is, hey, I'm busy. Okay? The next message that it sends over the same interface is that somebody asked me to execute some code, right? And so all the listeners got it. And this message, if I look at it in its purest raw form, will actually have the code that was sent. So this is a prettier JSON rendering of that initial message that was sent for execution. It has some content and the code that's being used there. I'm going to go back to the rendered version just so it's easier to think about this. So the execute input went through. It completed that request, and now it's going to send an execute reply. So it comes back with an execution count of 9, saying that this is finished, and it also sends back the result of this execution, and then it goes back to idle. Okay. So then let me clear these messages out, and let's see what it looks like when you have some syntax error. Similar thing. First we go to busy. Then we broadcast to everyone that we got some kind of input. Then we send back a message saying, hey, there was an error executing this piece of code, okay, because I didn't close some parentheses there. And then it sends off an execute reply. And the execute reply here contains the fact that it's an error, the fact that it is an error. It also contains a traceback, which has some terminal escape codes for this nice syntax highlighting that you get when you get an error. Okay, and then it goes back to idle. Okay. Then let's look at another sort of scenario. What if we just have some standard out that we're sending? So the raw message that we're going to send is print hello JupyterCon. And the result that we're going to get back is, back to the rendered view, is a stream message that contains just hello JupyterCon. Okay. Again, there's an execute reply, and we go back to idle. And then finally, sort of combining all of this with fancier, even fancier results. There's a pause there you may have seen. So first, I'm going to display some rich output. And then I'm going to, so first we go to busy. Then we go the fact that there was some sort of input request. We're going to display a rich object, which is the equivalent of print. Here is the result of that rich object. And then we're going to put an image as a result as well, and then go back to idle and give a reply. These messages, because they're coming on different channels, they're not sort of, the order isn't guaranteed between them because 0MQ, those messaging queues are separate. Okay. So that was a little demo. The anatomy of a message, again, I sort of touched on this. You would want to read the messaging spec in order to implement this faithfully. But there's different kinds of messages going through. We've seen the status messages going through, an execute request. There's a lot of messages are request reply pattern, right? So there's an execute request and an execute reply. Same with an object info. There's a complete request and a complete reply, and so on. And then there's the various kinds of content that might be depending on the message type. So an execute request would need to have the code that you want to execute, and an execute reply would have to have the execution count, for example, so that the various interfaces could provide that. Okay? And just to touch on the different channels, so the shell channel that you're sending messages over is individual, so that when I am operating on this notebook and I send a tab complete request, I'm the only one that knows my context. So everyone doesn't need to know what I want to tab complete on. On the other hand, when I send off execution, every other person, or every other client rather, would want to know what it was that actually happened, right? So tab completion hopefully usually doesn't execute any code. That's not always true, but you get the idea. Whereas sort of IOPub, as I said, it's a broadcast. Okay, and just to touch on how, again, how this works is there's the connect info magic. So if you wanted to, you could also snoop on this. Right now, what we did is we snooped on this session and interacted with it through a web-based front end. You could also do it directly over 0MQ. And so clients like Interact go directly just in this layer. There's no notebook server. There's just a client that speaks 0MQ to the kernel. Okay, so hopefully that makes a little bit more sense to you. Now I'm going to hand it all over to Matthias, who will talk more. Thank you.
Thank you very much. Does that work? Yes. You're going to see me struggle a lot because the scrolling is inverted. We don't have the same preferences. I'll try to do my best. So thank you, Paul, for all this introduction. So now I'm going to. You've seen a broad overview about the protocol, and the nice thing is that if a kernel or if a programming language implements a protocol correctly, then it will work with any front end. I'm going to dive here into two parts of the protocol, two really subparts, which is the rich display messages and tab completion. And in particular, I will show you both how they are used and how they could be used, things that are not completely implemented in the current frontends. I have custom patches that you will see here, and also in kernel with custom patches and tab completion as well. So display messages. So display messages are part of the Jupyter protocol, which allows the kernel to send data to be displayed to the users now or later. So for example, when you're in the notebook and you do something, you ask for 2 plus 2, it will send, hey, display 4. That's going to be displayed immediately, but it can also be stored in the document, which means that if your kernels is restarted, or if you send the document to someone, this information can be displayed later. And you have to keep that in mind, that the front end may change. You might open a notebook in Interact, close Interact, and open it in the notebook, and both don't have the same ability to show data. On the wire, it's part of the IPython channel, which means that it's broadcasted. And if you look really down, we have the display data formats, which look like that. We have 3 fields, data. I will come back to data later. You have metadata. Metadata is extra information. If you ignore this information or if information is missing, then the result should still display correctly. So for example, if you have an image, you can say, hey, I have a preferred width and a preferred height, color profile. And that can be ignored. And you have a transient key that for information that only makes sense while the kernel is running, which means that if you store that in a document, you should drop the transient field. The data field is a MIME-typed key dictionary. So the key are MIME types. So for example, text plain or image/PNG. And the value are whatever is relevant for this specific MIME type. And when you display an object, what the kernel will do is look at the various languages it can interact with, because you may not have only a single interpreter in your kernel. It gets all the MIME type from this object, bundle them, and send them to the front end. So for our notebook front end, the notebook front end will store all the values so that after the fact you can pick that up even if the kernel has restarted, which for example allow a posteriori choices, and that's something that I will show with new patches. You can choose even when the kernel has restarted which version of your object you see. And for example, if you save your document and reopen it with a front end that are extensions that understand new MIME types, then they can be shown after the fact. In IPython, how you do that? So far I haven't said anything about any language in particular, but here I'm going to focus on how IPython and the kernel, IPython kernel is doing that. To have a MIME bundle for an object, when you're controlling the object, you can define wrapper star methods. So for example, wrapper PNG, wrapper HTML, and this function should return data for your specific MIME type. Or if you don't control the object, because for example, they're not from a library you're writing, or they are, for example, in the core of Python, you can register formatter. You can tell IPython, when you see a list, I actually want you to use this to format your list in HTML, in PNG, in GeoJSON. I don't know how you would display a list in GeoJSON, but you could. So it is triggered in 2 cases, when you display an object or when an object in IPython is a result of the last expression of a cell. So let's see what it looks like. Here it's big. I'm going to re-show that in a demo. I'm showing it bigger in the slides. So you define an object and you create a wrapper HTML, a wrapper Markdown, or for example, a wrapper LaTeX. Or you can register formatters. How you do that? You get the current instance of IPython. Here it's too small. You basically should say here it's written text HTML. So you get the formatter for text HTML. And you say format formatter. You give it a type and a function that take an object and return data. So for example, I'm going to do something useless here when I'm using a request. I don't like the way a request represents its responses. I want to have this is a response object. So I would do it this way. I would import response from request and tell to the HTML formatter, when you see a response, use this function to format it. And then if the front end supports HTML, it will show that. And so for example, if I call request.get api.github.com, it should just work. So let's try to do a demo. It's not my computer, so here. So here is my multi-MIME types that I defined in my slides. I'm going to run it, and you see that here I have this is HTML. This is
Do you want to clear the input? Do you want to clear notebook?
Yeah.
No.
Let me. Oh, it's not my computer. wrong keys. Let me do that. Clear all cell output. Let's rerun that. So here I have a selector, which is new. This is a custom patch. And you can see here that I have an HTML representation, and I can actually change it to Markdown. And what I can do is actually restart the kernel. So my kernel is dead. I can try what is multi-mime. It does not exist. But because all my mime types are in the document, I can still change after the fact and look at what is a plain text representation or what is the HTML representation. Okay, so let's see if we can push that further. I have here a list of images, covers from books of a pseudo-publisher which might be around, like Editing Big, Avoiding Dark Patterns. But this is hard to see because it's a list. It's a list of things. So let's see if I can extract one of these and show it as an image. Well, so that's a cover. But I want to see all the images in my list. So let's look at the data. We see that these are PNG. I can only get 10 of these and wrap them in an image formatter for IPython. But sadly, even if an image can be seen, when you put these images in a list, the list doesn't know how to display itself as HTML. So I can't really see the covers of my books here. So what I will do here quickly is go through how you define how the image object works. So what we just do is actually get the data from the PNG, transform it into base 64, make it into an HTML tag, and then send this HTML tag to the front end. So now I'm just going to rewrite a function that does that here. And you can see that if I pass it my image data, it displays the same thing. And now I can use that if I'm a beginner with IPython, to create a custom container which is able to show images. I'm going to get that a vignette list. So I'm creating my wrapper HTML, get the wrapper for all my objects inside, join them in a pig tag. I'll also define a wrapper LaTeX. And now, if I pass all my objects to this custom object, now I have the ability to quickly see what is in my list, and I can look at the various representation. This is great, but I don't always control how my different API are returning things. You might get something that returns a list of images. So you want to teach IPython, I want you to display a list of images this way. I'm just going to do the same as above, slightly fancier because I want drop shadow when I hover with my mouse. And now here is a crux. I'm getting the HTML formatter, and I tell IPython, well, when you see a list, use this HTML formatter. Use the HTML formatter for my list. So let's look at my list. My list is just a normal list. Let's register an HTML formatter. Let's look at my list, and boom, I have my images, which means that now any list of images you have will be able to display. And I've also done that recursively, which means that if I make a list of lists, so let's do 2, 5, and let's do my list of, I don't know, 1, 3, and put that in a list. I have a list of lists, and it works as well. You see that I have double square bracket here, square bracket here, square bracket here, and double square bracket here. So it works recursively with list. And this is not the right notebook. Let me do that quickly. You might not want to write that in all your notebooks. So actually, what you can do is install library. We have a library in the IPython repository, which is still in progress, that provide a display formatter for external objects. So for example, if I import, oops, it's not installed, so I can't do that. Okay, it's fine. So you can, I have it for request, for example. If you use request and you do request.get and a specific endpoint, it will get that for you and show a representation where all the headers are collapsible with an arrow. So you don't have to dig into your response content and so on and so forth. And if the reply is JSON, it will also automatically detect that and show that as a collapsible tree. So when you're using your API that are JSON, you don't need to ask request to get the JSON and parse it for you. you will just see everything. So let's get back to, I don't know.
The other one, yeah.
Yep. Okay. So we saw here that the kernel uses display mechanisms that are not native to the language. Wrapper HTML and display formatter are not specific to Python. Here we have the chance to have the IPython kernel written in Python and the Python interpreter being there, so it's kind of difficult to see that. But for example, there are kernels that are written in Java, which means that you can actually in your kernel use Java code to display R object. So it means that you can you can use a formatter in one language to display an object in another. And the kernel is, here our IPython kernel run one Python interpreter, but it doesn't need to run only one interpreter. It may be able to run also, for example, an R process and communicate with R process. So you can use formatter in Python to use R. We saw why we wanted to send all the MIME type. Because now that we have the things, we can still switch after the fact. And if you were to save this notebook and send it to someone, and for example, the list were to again have the GeoJSON representation, then if you open it in Interact would show the GeoJSON representation, and Jupyter Lab would show the GeoJSON representation because they know what GeoJSON is, while this notebook does not. And so you want to really send everything and not assume that you have a specific front end connected to you, so that you can make full usage of the Jupyter protocol. I'm going to now go into tab completion, which is another part of the protocol. So tab completion, what is tab completion? Well, it's a shortcut for the users to go from one state of a document to another state. Most of the time, we think it about appending text because we were used to read line. That was the terminal where you could only append text. And for most editors, you will have static analysis of your code you're running because you don't have a current state which can help to tab complete. But the Jupyter tab completion is slightly more, and more and more editors are using something which is better. So the way the tab completion in Jupyter works is on the shell channel, which is not broadcasted to all clients, because as Paul said, when you tab complete, it only makes sense for you who ask tab completion what the reply is. You send the code in the current cell for the notebook. That's what the notebook does. It could have concatenated all the cells, but we decided that it was just the current cell. If you do the implementation, you may decide to do something else. And you give a cursor position. And the reply is a list of patches which roughly look like replace from this position to this position by something else. There are more detail in the exact documentation. So for example, this allows us to do things like completion of Unicode characters. You know that it can be quite complicated to complete the Unicode characters. Well, in a notebook, if you do \alpha and you press tab, because we don't only append, but we can remove some things and can replace by the patch, you can replace by this alpha by the Unicode alpha symbol. And as in Python, you can use Unicode identifiers, then you can write short code in Unicode. If you make a typo, like for example, you try to type matplotlib but can't type it because you're on a French keyboard, or a German keyboard, or a Dvorak keyboard, we can erase what you've done and replace by matplotlib. For those of you who've heard about Microsoft Language Server Protocol, those are more akin like text edit. And the thing is, because we have a kernel, and the kernel is not exactly the things that execute the code, it's the things that decide what to do for the users and dispatch, then the kernel can decide to do completions depending on which state you are. So the kernel may decide to do static analysis and say, I'm just going to see the variables that are around, and I'm going to dispatch a completion. Or it might be able to do inspection of the current states. Oh, sorry.
Yeah.
It's difficult.
There you go. Matthias, 5 minutes. Bye.
OK. Let's do that quickly. So for example, if I do L equal a string and 1, and now I do import random and element equal random. So here I'm doing static analysis because random is not imported yet, and choice because choice is not imported yet, I can get an element from L. But here, if I do EL dot and I want to complete, I cannot do static analysis because you cannot know it's a random choice between a string and an integer what it is. But here, I see that I have bit length and conjugate, so I can infer that EL is actually the integer, so it's 1. And because the kernel decides to dispatch things, I can load here. I've just hooked my interpreter into a SQL interpreter as well that can run code. And the kernel can decide, hey, I am actually not going to ask Python to complete, but I'm going to ask a SQL interpreter to complete. So let's check that this variable is not defined. So no, it's not defined. And now I'm going to try to write some SQL. And you see here that because the kernel sees that it starts with SQL, it says, I'm going to dispatch the type completion to the SQL server. And now if I press tab, I'm going to get select. And now I can select the cover. And let's get red cover from our O'Reilly books and get only 5. And I get all my things. And you see that here, my kernel is able to both dispatch to a Python interpreter and to a SQL interpreter. I see some people smiling in the room, so just don't read the covers. And the kernel is able to use the Python function I have defined to represent my images and my list of images to just work. And it also have injected the variable that was not defined before into my Python interpreter, which means that here I have 2 languages in the same kernel. And you see that I have my penguin here, so good enough to ship. So that's close to the end of this demo. If you want to know more, there are a couple of examples, and there was a tutorial 2 days ago from Laurent Gauthier that's showing you how to use R, Python, and SQL in the same notebook. And we have a notebook around on the internet if you search that are mixing way more languages. Like you can have Julia, Fortran, R, C, Python, Rust in the same notebook, and they all communicate with each other and call functions from each other. So you can have a kernel which actually dispatch to a large number of interpreter. And I'm now used the right shortcut. So kernels are more processes that manage user requests. They're not attached to a specific languages. They may decide to dispatch things. Implementation can be different than the language they're running on from. So for example, the metakernel in Python can dispatch to many different languages. And Zeus is, there is a talk about Zeus later, which is a C implementation of most of the protocol. You just have to overwrite a couple of functions and you have a kernel that almost have the complete spec. You've seen that most of that are custom patches. So even the default, the reference implementation, which is IPython, does not implement all the capability of the protocol, and there are really low hanging fruits. All the patches you've seen here for completion in CellMagic, for SQL, and for being able to select MIME type after the fact took me an afternoon to write incorrectly and hard coding a full completion, but just don't tell anyone. And a lot of detail haven't been seen here, and we are only mostly scratching the surface. It's not complicated. There are a lot more improvements we can do, and I hope that gives you a nice overview of what the Jupyter protocol can do, and how you can use it at your advantage. And here are a few related talks that some of them are this afternoon. I would advise you to go see them if you're interested, and we'll take question for 1 minute, I guess. Thank you.
We have 1 minute for questions. You showed like some kind of kernel debugger or like application that looks pretty cool. Is there any way, and you talked about, if your kernel is, I guess I'm asking is, do you have any tools for validating that kernels follow the protocol correctly?
We have something simple that's that you write some Python for. It's not very good. It needs more work. Yeah, absolutely. And that's something that we want to standardize this interface more. I should have mentioned that the protocol is versioned. So one of the fields that you send with a message is the version number. And so as we adapt and expand the protocol, you'll be able to either write adapters to conform to new versions of the protocol, or just hard code the specific version that you need. But yeah, that's exactly the sort of things that we need. So in the Jupyter repo, I think there's some Jupyter protocol tester.
The question was is there a tool to automatically check kernels and verify that they respect the spec? It's somewhere, yes. It's not well maintained. We need more people to look at that. But come and see us. We can give you the exact repo later. And come to see us outside if you have more questions. We need to switch speaker.
Thank you so much.